Variety is the spice of life, and walking is good exercise. If you combine these two things, you get a random walk. As the name suggests, in a random walk, your direction is chosen at random at each step along the way. Today, we will use Python to solve a random walk puzzle using Monte Carlo simulations. This concludes my Gamble-Amble preamble. Suppose you live in a city where the streets are arranged in a perfect grid. You decide to go for a walk. At each intersection, you choose your next direction randomly. Your 4 choices are north, south, east, or west, and backtracking is permitted. Once you are finished with your walk, you check to see how far away you are from where you began. If you are more than 4 blocks away, you will pay for a transport back home. Otherwise, you will just walk. What is the longest random walk you can take, so that on average you will end up 4 blocks or fewer from home? We will begin by writing a function to simulate a random walk of n blocks. We will write this function twice. The first version will be clear, simple, and straightforward. In the second version, we will use some Python shortcuts to cut the length of the function in half. To begin, import the random module. We will call our function random walk, and the input n will be the number of blocks to walk. Write a short docstring describing the purpose of this function. Your position in the grid will have an x and y coordinate. Initially, x equals 0 and y equals 0. We will now take the random walk. To do this, we will use a for loop with n steps. To pick a random step, we will use the choice function. We will choose from a list of the 4 possible directions: north, south, east, or west. If the random step is north, then increase the y coordinate by 1. If it's south, decrease the y coordinate by 1. If it's east, increase the x coordinate. And now the only remaining alternative is west, so for the final else block, decrease the x coordinate by 1. At this point, the walk is over, so we return the coordinates as a tuple. To test this function, let's take 25 random walks, each 10 blocks long. For each walk, we will display the coordinates and the distance from home. The distance from home is the sum of the absolute values of the x and y coordinates. This is because the sign is for direction, not distance. For example, suppose you ended up at x equals -10 or x equals 10. In both cases, you are 10 blocks from home. The sign only indicates if you are east or west from your starting position. Now run. Everything looks to be in order. Before solving the puzzle, let's write a second version of this function that is more compact. We will call this function random walk 2. We will perform our solemn programmer's duty and write a docstring. As before, let's initialize x and y. In Python, this can be done in one line. This assigns the first 0 to x and the second 0 to y. Once more, we will use a for loop to simulate the n blocks. Previously, we randomly chose a letter and then used the letter to update the x and y coordinates. This time, we will randomly choose a pair of numbers dx and dy, which will contain the values we will add or subtract from x and y. We use dx and dy as abbreviations for difference in x and difference in y. Now we randomly choose a direction. If north is chosen, the x-coordinate does not change, but the y-coordinate increases by 1. If south is chosen, x is again unchanged, and y decreases by 1. For east, x increases by 1 and y is unchanged. And finally, for west, we subtract 1 from x and leave y unchanged. We now use dx and dy to update x and y. X plus equals dx is shorthand for x equals x plus dx. We update y the same way. And finally, return x and y. Let's now test this function to see if it behaves as expected. Like before, we will take 25 random walks. Each walk will be for 10 blocks. And we will print the final coordinates along with the distance from home. Run. No errors and no surprises. Let's now return to the original puzzle. What's the longest random walk you can take so that on average you will end up 4 blocks or fewer from home? In other words, there is less than a 50% chance you'll pay for transport home. This can be solved mathematically, but instead we will use the Monte Carlo method. This technique is named after the city of Monte Carlo, a gambling town on the Mediterranean Sea. You will never find a more wretched hive of scum and villainy. Here, instead of solving the problem mathematically, we will conduct thousands of random trials and compute the percentage of random walks that end in a short walk home. To get an accurate number, we will take 10,000 random walks for each walk size. Let's estimate the probability you will walk home for walks of length 1 to 30 blocks. Don't forget, the range function stops before the final number. Let's create a counter called no transport to keep track of the number of random walks that end 4 blocks or fewer from home. Let's now begin our Monte Carlo loop of 10,000 samples. First, get a random walk of walk length. Next, compute the distance from home. If the distance is less than or equal to 4, increment the no transport counter. We can now compute the percent of random walks that ended with a walk home. It's just the fraction of the 10,000 random walks which required no transport. And finally, print out the results for this walk size. Run. Fascinating. The longest walk with a greater than 50% chance of walking home is a walk of size 22 blocks. Let's run this simulation one more time, and to increase our confidence, let's use 20,000 random walks to estimate the probability. There you have it. We get the same answer. By the way, your numbers will be slightly different from these. That's because Monte Carlo methods use random samples, and different simulations should give slightly different results. Observe that walks with an even number of blocks leave you closer to home than walks 1 block shorter. In general, even walks end closer to home than odd walks. I encourage you to discuss and analyze this phenomenon in the comments below. Random walks are a fascinating subject. They are used to model many different problems, from the motion of molecules in a fluid to the movements of stock markets. As a challenge, try to find the longest random walk which will, on average, leave you less than 5 blocks from home. And, as a courtesy, please consider subscribing to Socratica. The more support we have, the less random our release schedule will be.